1 mole of an ideal gas occupies 22.4 liters at standard temperature pressure and has a mass of 1 gram. We can readily calculate the density of an ideal gas under these conditions. So let's look at 2 examples. Calculate the density of nitrogen at STP. So I know that ideal gas is PV is equal to nRT. Well, I know that I want volume on the top for density. So density is equal to gram over liter. Well, if I want liters on the top, I'm going to need to manipulate this equation to get volume on the bottom. And I need to get grams in there, so I have to use molar mass. So this manipulates around if we end up using molar mass and we say that density is equal to the pressure times the molar mass over our constant time temperature. Pressure here for standard temperature pressure is 1 atm. Molar mass for nitrogen gas is 28.01 grams per mole. And our constant is 0.0821 liters atm mole Kelvin. And then the temperature is 273.15 Kelvin. If you multiply all that together, your answer comes out to be 1.25 grams per liter. Now the next one says calculate the density of a gas at 275 torr and 27 degrees Celsius if 0.250 moles weighs this mass. So there's one of 2 ways to do this. You could plug it all into the question that I just did or do it separately. Density is mass over volume. So you can use ideal gas to get volume and then divide it by the mass. Your temperature is 27 degrees Celsius plus 273 gives you 300 Kelvin. And then your pressure you divide by 760 since 1 atm is equal to 760 torr, which gives you 0.993 atm. And then that equals to 6.2 liters. And then for your density, you take your mass and divide by the volume. And that gives you 1.61 grams per liter. You also could have used this way up here and plugged it all in and you would have gotten the same answer. So know that if rearranging the equation doesn't make too much sense, you could always just solve for one variable and then use standard conditions if it's at standard conditions or use the mass. Since we have R has moles in it and N would cancel out those moles. And we have also mass, instead of writing N, the question is rearranged to have pressure volume times mass is equal to molar mass times R constant over T. Molar mass is grams per mole, R is over moles and liters, M gives you grams, so everything would cancel out. Since you want density, you want M over V. So what happens then is you will get that the density is will equal to the mass over the volume will then equal the pressure times M, and I should say that these are flipped. So this is little m, and then this is the big M. So mass over volume, your density will equal your pressure times the big M divided by RT. So that's where those units come from. If it doesn't make sense how to rearrange the equation, you can always just solve for the grams from the moles or the volume and then find density doing grams